Welcome to Unpacked, the podcast that examines how technology is reshaping business and our world, with this season unpacking the big topic of generative AI. My name's Stuart Black, and I'm joined by the voice of the show, Think Tank's innovation lead, Arvind Ravishankar. Arvind, how are you? I heard that you've been away.
Yeah, Stuart. I was in Costa Rica for a couple of days. It was just amazing.
Very nice.
It was absolutely amazing.
We're going to talk about your deep dive interview with Vivek Farias, who is a professor at MIT. Can you explain a little bit about what we're going to hear today?
Oh, absolutely. Stuart, we're all very familiar with how humans learn, right? And we've been through the learning process ourselves with about 20 years of education. The question is, how does AI learn? And that's what we're going to be diving into with Vivek. So I'm super excited about this conversation. Being a professor from MIT, Vivek has spent years on this topic, and so he's going to be unpacking that with us.
Oh, fantastic. But before we get to the interview, we've got a couple of talking points from the AI world to have a look at. Our first story today comes from the Washington Post and examines how generative AI is being used by university students in the United States today. The answer seems to be quite a lot. Not only are students planning and sometimes composing their essays using tools such as Lex, WordTune, and of course the ubiquitous ChatGPT, but it's getting increasingly hard to detect when they are doing it, even when their professors are using AI tools developed to spot the difference. The article suggests that this trend is unlikely to be reversed. So Arvind, what do we do about this? Is it a serious concern, or is it the same as kids using calculators in a math class?
So Stuart, I think the implications are a lot broader than what this article is talking about. I think AI is going to blow open education completely. It's going to change every aspect of education. And, students composing essays using AI is literally the tip of the iceberg, right? I do believe that AI will change how students learn. And more interestingly, I think AI is going to fundamentally reshape what we learn and what kind of skills we need to develop, right? So in the example that you're talking about, where students write essays, what is the skill they're developing? Is it about reading comprehension? Is it about analytical skills? What is the skill? And tomorrow, if AI can actually perform that task, and maybe perform it better than a human, then what should we be teaching humans of the future, right? So there's a bigger question here on education. What should humans learn, right? And traditionally, we've looked at education to some degree, if you would agree with me. Most of education today is biased towards survival. Like, you learn so that you can learn a skill and you can go to work and you can earn money for your family, right? But in the future,
right,
is education going to play the same role, or will education be more about knowledge and thirst and an expansion and understanding of the world, right? So it's going to be interesting to see how it plays out. I think AI is going to blow open education completely.
Exciting stuff, so watch this space, as with so many other spaces. And our second story addresses what I would say is maybe a parallel issue, this time for the $68 billion industry that's developed around search engine optimization, or SEO. This is an article in Fortune that suggests pretty soon AI-fueled internet searches will no longer need to direct users to links and URLs, but contain everything you need to know within a simple text reply. That could mean the SEO industry, along with paid placements and banner displays, sponsorship, all becoming obsolete. Arvind, if this is the case, it's quite a profound change for the economics of e-commerce. One of the implications of this is that Google, who's been so dominant in this field for such a long time, is now facing stiff competition. What does it mean for Google?
Yeah, I think, Stuart, I think for the first time in almost 20 years, Google's facing real competition, right? And so that's really interesting. Now, the thing about Google, though, is I wouldn't say that, we're not dealing with a situation such as Blockbuster and Netflix, where Blockbuster was so much behind the 8 ball that they completely missed the trend. Google's in a different situation, right? They've been actively investing in artificial intelligence. And in fact, a lot of the architectures today used by OpenAI, ChatGPT, etc., came from Google, right? The transformer architecture was developed by Google. However, that doesn't mean that their business model is not under threat, because the idea of search is going to change. I mean, if you think of it fundamentally, the reason we search is we're looking for new information. And if there is a better way for you to consume that information, if there's a more precise way for you to get answers and also interact with the search engine in a more human way, you're going to do it. And so I do think that search is undergoing a transformation. Now, the broader question of, does that change e-commerce? I don't think it changes the size of the e-commerce market. In fact, I think it increases the size of the e-commerce market. And I think people who are in the advertisement space or people who want to advertise are going to have abilities to target users more precisely, right? Provide more personalized recommendations like never before. So I think e-commerce is going to benefit tremendously from this change. However, Google, as their business model, search is going to change, and we're going to see who is going to be the number one competitor for Google in the coming years. Is it going to be Bing with their new search engine, or is it going to be ChatGPT? Don't know.
Yeah, and one of the things that always strikes me is when you type in your search into Google, the results can just be boring, just a bunch of links. And now with AI, you've got much more rich, in-depth results that are much more fun as well.
It is, and also interactive, right? You can interact with those results, right? You can say, okay, hey, you're planning a vacation for your family. I'm interested in taking my family to the Asia Pacific region, right? And the search engine may now reply, or the AI may reply, what are you interested in, right? You could say, hey, I love scuba diving, or I love parasailing, and it may be able to curate an entire vacation for you. So imagine spending 20 minutes with an AI engine where it curates a vacation for your entire family based on what you're looking for. And now imagine if that AI engine is tied to all the tourism agencies of those regions. It could even book the tours for you directly. It could tell you things like, rather than you having to search for everything, it could preemptively tell you that, if you're interested in scuba diving, this is the number one agency to go for it. And I know that they're booked out often, so please book it in advance. So this kind of interaction is going to be game changing. It's going to be game changing.
It sounds too easy. Was that how you got to Costa Rica, perhaps?
Unfortunately, no. But now that you tell me, I should have used ChatGPT. I landed up using Google search a lot, but next time, yes. Now that we've spoken about it, I think I'm going to do it. But interestingly, I tried this with other things. Right, going back to the education part, interestingly, Stuart, the theory of relativity by Albert Einstein, right? That's a really interesting theory, and it's a nuanced topic and not easy to wrap your head around. And I've tried reading about it in physics textbooks, and it never really appealed to me, right? The way it was being described. So I spent about 15 minutes with ChatGPT and prompting it in different ways. And it was able to teach me about theory of relativity in a more simpler, easier fashion than any physics textbook could. So this is why I think that it's a game changing, right? Education and search, both are going to be completely different in the next 5 years.
Promise me you will send me the search that you made there, because it sounds like I need a bit of educating on that one as well.
Oh, sure. I think if you know how to write good prompts, if there's any takeaway from these two topics, at least for the next 1 year, everybody should learn how to write really good prompts. If you know how to write really good prompts, you can do wonders with AI.
That's the secret.
That is the secret today.
So Arvind, can you tell us a little bit more about what you're focusing on in today's interview with Vivek Farias?
Sure. Stuart, as enterprises bring out these new AI products and services, the reliability of the AI and its ability to engage, work with customers, and provide the right information is top of mind for enterprise leaders, right? And we've learned in some of the other episodes that we've discussed so far that the quality of the product that you're releasing, the AI product, is very much dependent on two things: how the AI model learns and what data you give it. Right? Those are two determining factors of the quality of the AI product. And so today I'm going to unpack with Vivek on how an AI model learns. So that way you know how to ask the right questions. When you're choosing the AI models for your company, you know what questions to ask and you're familiar with how AI learns. And so Vivek and I will be unpacking that. And given Vivek's background in MIT and the last 20 years of work he's done on AI model training, I think this is going to be a really interesting topic.
Great stuff. So without further ado then, let's get to Arvind's deep dive interview with Vivek Farias. Our think tank focuses on researching emerging technologies that will shape your future. From generative AI to exoskeletons, we study the impact these technologies will have on business, humanity, and our planet. And through our podcast, newsletters, and social media content, we have a direct line to a truly global emerging technology community. So if you'd like to find out more about the impact these technologies will have on your business, then reach out to our team at lab45thinktank.com.
Hi everybody. Today I have an exciting guest who's going to talk about how we teach machines to learn. And specifically, he's going to talk about systems that have really led to the breakthrough of things like ChatGPT. He's a PhD from Stanford, and I'm really excited to have him here with us. He's also a professor currently at MIT, where he teaches hands-on deep learning, and he also teaches the Sloan Fellows. He founded two startups. The first startup that he founded, Select, in the area of AI and retail, was acquired by Nike successfully, made an exit, and today he's got his second startup called Simulate. I'm super happy to have Vivek Farias, professor at MIT. Vivek, I'm looking forward to unpacking AI and learning with you.
Arvind, thanks for having me. Very excited to be here.
Fantastic. Awesome. So, Vivek, I'm going to start with my favorite question, which is what drew you to the field of artificial intelligence? What kind of got you into this area?
It's a great question. Yeah, I'm actually quite excited to answer that, actually. So, when I was an undergrad, which is in the late 90s, there was this whole thing around, it was called RoboCup, which was sort of robotic soccer. So I started doing this RoboCup stuff when I was an undergraduate. I'd make a huge amount of progress, actually. When I was an undergraduate, I was kind of involved in lots of different research. But then, when I started graduate school, I was sort of excited about all this RoboCup type stuff. I was also interested in kind of like the notion of, kind of interacting with an uncertain environment, right? You go do something, the environment does something to you, and you do something back, and the whole thing continues,
Yep.
right? And so my advisor in graduate school, his name's Ben Van Roy, right? And so I talked to him about all this stuff. He said, well, here's kind of a cool, a cool little project. Why don't we work on building a computer player for Tetris, right? So if you think about Tetris, it's a really simple uncertain environment, actually, right? Like, what are the next, which of the next pieces? There are 6 types of pieces, so which of these 6 is going to fall? I worked on that, kind of built a Tetris player that worked really well. To be clear, I've done lots of other things beyond Tetris. But yeah, that's kind of what drew me in.
Vivek, I love this framing, right? Uncertain environments. I'm sure our audience can really relate to this because we are in such an uncertain environment today with artificial intelligence, right? The area today I want to unpack with you is the area of reinforcement learning. So maybe you can start with telling us a little bit about what is reinforcement learning and what role does it have to play in this world of artificial intelligence?
So reinforcement learning is, But at like a philosophical level, it's exactly what I talked about earlier, which is, if you are interacting with an uncertain environment, right, and that environment could be the world, it could be a video game, it could be a warehouse, it could be whatever, right, and the agent could be you yourself, or a trading algorithm that's trading the stock market, or a robot, right, or whatever it is, right. There's this sort of, the agent interacts with the world does something to the agent maybe earns like some reward or loss, and this whole game kind of continues with the objective of, sort of maximizing, what might happen, right. It's
Yep.
just a complicated optimization problem. It's central to kind of what makes reinforcement learning separate from a generic optimization problem is the role of uncertainty. Reinforcement learning is basically, at the end of the day, this balance between exploiting what you know about your environment and optimizing against it.
What's interesting to me is the underlying premise is that without uncertainty, there is no learning, right? To some degree, you need that uncertain environment in order for you to learn.
Yeah, yeah, yeah. So I wouldn't conflate these things. So I think we're talking about two
Okay.
things here, actually, right? We're talking
Okay.
about really what your utility is for what might happen, right?
Yep.
And there, people can have different attitudes towards risk, right? So you could be risk
Yep.
averse, you could be risk neutral, yeah, you could be risk seeking potentially, right? So there are various sort of objective functions you can actually have, right? But irrespective of those objective functions, right? One thing that's kind of, you know, irrespective of our respective risk postures, right? One thing that's clear is that hopefully we're all maximizers. That's kind of
Amazing.
like the
Okay.
mindset I think
Yeah.
that unifies this whole thing. You can layer on top of this risk tolerances. There are lots of domains where the risk is real, right? Like imagine you're building a robot to do something, right? If the robot does something crazy, that's really bad. That's disastrous. And so objective functions often do have to capture risk, but that doesn't let you, kind of, shall we say, abdicate away from kind of thinking about, the payoff over the long run.
No, this is amazing, Vivek. In fact, I think if anything, what the business world has taught us over the years is that those companies that have that balance of certainty and uncertainty are the ones that succeed in the long run too. I think that was a super important insight, not just for the world of AI, but honestly, it applies to the world of business and how we run business, right? So coming back to this reinforcement learning, so tell us how this applies then to artificial intelligence. Specifically, let's talk about LLMs, right? These are the new age of AI. How does reinforcement learning apply to LLMs? And maybe if you can take an example of some of the current LLMs that have risen to popularity, what allowed them to rise to popularity, and how did this help?
So reinforcement learning has played a central role in getting you kind of general purpose chatbots and things like that. But its role has been kind of more as an optimization paradigm as opposed to anything else, which is not bad, or it's not right. It's not a bad thing. It's just that it has been kind of, let's say, the enabling optimization paradigm, if in
Hmm.
like kind of one sentence, for some of the LLMs we actually see. So just to kind of maybe click into that like kind of one level deeper, right? Um, by the way, right, folks, some of you have potentially heard of this notion of RLHF, reinforcement learning with human feedback, and oftentimes you hear about that in, kind of in concert with, how was ChatGPT built or something like that, right? Um,
Yep.
so let's kind of dig into what that is, right? Let's dig into what that is. What is an LLM, right? So if folks have been following along with your podcast, they hopefully know the answer to this, right? But
Yes. Hopefully.
right, an LLM is something that takes in a historical sequence of tokens, right? You'll often hear this word tokens, right? But for now, let's think about them as words, and it gives you another token, right? It just gives you another token, and you know, whatever, right? Like GPT-3, GPT, all of these things are models that effectively, just given a history, give you a conditional distribution on the next token, right? Functionally, that's what all of these things do. You could ask the resulting model questions, but oftentimes the answers you get back are gibberish, right? And that's because these models are just trained to kind of autocomplete text at some level, right? And so they're just representing the corpus that they were trained on, which is largely the internet. So the big kind of jump, so to speak, between these pre-trained models and like the what the experience we have, let's say, right, with some of these more application-focused models, let's say ChatGPT is an example of such an application-oriented model, where that application is a general-purpose chatbot. How do we go from there to there, right? Like, how do we go from A to B? How do we make that happen? Largely speaking, the way that happened was this insight that, like, hey, we've got to align this underlying model to the task we wanted to do, right? So, if I was trained to autocomplete on the internet, it's unclear I'm going to be good at like being a general purpose chatbot. So instead, let's actually align these models to being good general purpose chatbots, right? And so the mental model would be, right? I have the original model, the original pre-trained model. I now have a whole bunch of examples, so to speak, in the form of instructions, right? Like, here is a question, here is the appropriate answer, right? And at some level, I want to quote unquote fine tune that underlying pre-trained model based on this corpus of instructions to become really good at whatever task that set of instructions was for. So if the instructions were like general purpose, you get ChatGPT, but those instructions could be different. They could be instructions that are, really good at maybe preparing a legal brief or something like that. And then you get some kind of legal GPT or something like that, right?
If I reward AI to do something bad, that's what it's going to do. It's a machine, it doesn't know. So, how you set up the reward and losses, is this something that enterprise leaders should be paying attention to as they deploy AI, as they train, fine tune AI models? They're going to have teams of, so for example, I'll give you an example. We have a utility customer, right? They have a lot of utility based data. And I'm talking about a power utility, right? Energy data. So if they want to train their and fine tune their models to take decisions, right? How they reward those models is going to make a difference in the fine tuning, right? You want to reward a model for identifying a fault in the electrical line early on, right? Or maybe you want to not reward a model for finding the wrong fault, or however that works, right? So can you talk a little bit about the setting up the reward and setting up the loss? How crucial is it? What sort of people do you have to have in your company? Do you have to have ethics involved? Do you have to have morality involved? How do you do that? Just talk a little bit about that, right?
So I think, first of all, I think there's examples that are very utilitarian in nature, right? Where I don't think we have to necessarily think all that much about the reward, right? Like for instance, where like you know everybody kind of agrees, so to speak, right? Like with your
Yes,
power utility
exactly.
example, I would imagine there's
Correct.
very little philosophy there, right? It's very clear. If there's a fault,
Exactly. Yep.
find the fault quickly. No, there's no problem with finding the fault quickly and as cheaply as possible, whatever. I think there's plenty of business applications where the objective is utilitarian and clear, right? I
Mm.
think your example with the power company is a good one. A different one, and like we can, you know, again, people can be of different minds here. But another one, the way I see it is kind of e-commerce, right? Like if I go to like
Mm.
a website, I know I'm going there and I'm going to be sold on stuff, right? And to the person that's running that website, I'm putting aside, I'm assuming that they're selling good things, right? And like putting aside like sustainability and how they produce that and all that stuff, right? Assuming they're doing good things there, just keeping to the interaction on the website between the customer and the person. Again, it's pretty well understood. It's pretty straightforward, right? The company wants to sell you on their product. You're there to solve a problem. And ultimately, if you're happy when you leave and they make money when you leave, great, everybody's happy, right? And again, you can kind of find agreement around these sorts of things. Um, Very utilitarian objective. I think where it gets much less clear, right, is I think where it gets much less clear, right, is when you start getting into things where there's judgment in the answer, right?
Yep.
So here's a great example about organ donation policy in the United States, right? So if somebody passes away, right, and they have a kidney that's available, right? There's a deceased donor organ. That organ is now available to people that potentially need a kidney, right? So most people, these are people on dialysis and so on and so forth. They need a kidney. What's the right objective here? Less clear, right? Because there's all these things to balance. On the one hand, like
Yep.
there's people, you could give it to somebody that's really young because they have their whole life ahead of them. On the other hand, you could say, hey, look, my mom has been on that list for forever, and now you're going to give this to somebody that's like been there for a year. So we can't, as a society, necessarily agree on these things, right? If you have a machine making these decisions, right, more and more, that machine had better represent at some level an agreed upon objective, right? And so it starts getting very tricky. Now, coming back full circle to the LLMs, right? Let's think about how you evaluate that answer, right? Like we did this really nice little loop, right? We said, hey, just reminding people where we were in the conversation. We were sort of saying, look, the LLM by itself just auto-completes. Now you wanted to get really good
Yep.
at being a general purpose chatbot. Great, in concept, that's really simple, but like, how do we think about this? And the first task is you need a reward model. So what is that reward model, right? And it's hard to I picked an innocuous example earlier, which was, tell me 10 things to do at a kid's birthday party. It could certainly be much less innocuous, right? Like it could be a question that has, that touches on, ethical foundations of things, or touches on, people's religious beliefs or whatever it is, right? So it could get much more murky, right? And somehow or the other, you want to describe this with a reward function, right? Which is like much less clear. And so, for better or worse, how do people do it now, right? Let's talk about that. Like, how are people doing that now, right? So the way people do it now is really represents or reflects really this idea of what's called revealed preferences. Okay, so revealed preferences. This is a notion from economics, right? And it goes all the way back to like folks like Paul Samuelson. Okay, Nobel Prize winner from MIT more than 100 years ago, right? Thinking through utilities and rewards, right? And the challenge was, listen, like when we do math, when we build models, right? We want these reward functions. But in the real world, there are no reward functions, right? Like, how do I evaluate things? And the insight was maybe one way of evaluating things is through quote unquote revealed preferences. So, what is revealed preferences? As the name suggests, it's basically saying, look, as a human being, if I give you the choice between apples and oranges and you pick apples, you're telling me you prefer apples to oranges. Now, if I give you kind of the choice between two sandwiches and you pick this sandwich over that sandwich, you're telling me something about your preference over sandwiches and so forth, right? You could take that same logic and apply it to answers, to questions, right? And you could sort of say, hey, look, I'm going to have this pool of human beings, right? They're going to see questions and they're going to see 5 potential answers to those questions, right? And all I'm going to ask them to do is tell me which answer they like the most, right? So in telling you what answer they like the most, that subsumes really all of their complicated decision making, right? Like whatever that may be, right? And all I'm going to do once I see these decisions is I'm going to train or learn a reward model that if I optimized against that reward model, it would give me the same answers as these human beings that are choosing. Okay? Now, and that could give you, and there's a mathematically reasonable way of doing this. It's actually no different from just supervised learning. Okay, it ends up being just a supervised learning problem at the end of the day, right? So conceptually, we've talked a lot, right? Let's just step back for a second and then we can dive back in, right? Really what we're saying is challenge number 1, and we've not even talked about RL over here, right? Like we're still talking about alignment. Challenge number 1 is, as I align kind of the underlying model to some end goal, be that, let's say that goal is a general purpose chatbot, I need a reward model. how do we build such a reward model when, like, it's like asking about very kind of non-quantitative things potentially at the end of the day. The key there is reveal preferences, ancient idea, right? And given those reveal preferences, I can just sort of use supervised learning to build a reward model that captures those revealed preferences. And so
Yep.
I think yeah, there's a ton to be done in terms of kind of thinking about how we go about building these models. There's a lot of thought that's going into kind of doing this in a fair, representative way. But honestly, I think there's miles to go over there.
I think so too, Vivek. I think there's a lot to go here. The whole idea is that the 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 preferences of the masses are represented as the way forward, right? So in this reinforced human feedback learning mechanism, is there an opportunity for us to almost set up systems similar to voting, where a huge group of humans get to say how a model is trained, how a model is learns, and what the revealed preferences are, versus just a few individuals doing that?
It's a much harder problem than it seems, right? Both kind of practically and philosophically. So philosophically, I think, and I don't want to take the conversation necessarily off kilter here, right? But
Philosophically,
philosophically,
totally valid. We are
there is no kind of perfect like voting system, right? Right? There's no perfect voting system. Let's just make sure we all get that, right? But then let's say you picked a voting system, right? Like you say, hey, this is the crowd and whatever. I think there's lots of pragmatic issues. So for instance, one might say, right, look, if you think about how ChatGPT is being trained, they didn't, beyond instruction training, beyond the original instruction sets. Now, OpenAI has hundreds of millions of users, and some of these users give, thumbs up, thumbs down on answers. If they so elect, in the settings, that can be used as further data, right? And so now you
yeah,
say, hey, listen,
makes sense.
I'm suddenly getting the opinions of lots more people, right?
Yeah, totally makes
Um,
sense.
but that too has its flaws, right? Because as you think about like who has access to OpenAI's ChatGPT, not everyone, right? It's a very biased group of people, right? Like, right? It certainly skews a certain way politically. It probably skews a certain way, wealth wise. So
Yeah, you're right. And
economically
I
and so
think
forth. So very hard, just practically. I think it's not a trivial thing to do, right? But I do think I do think like it's in everyone's interest at some level for that to happen, right? For that alignment to actually happen. It's certainly in the company's interest, right? In this case, because
it
to the
is.
extent that OpenAI wants to serve everyone, people are going to go there if they get answers they like, right? And so it had better like
It
capture
is.
everyone's preferences. So I think in that sense, there's hope. In that sense, I think there's some alignment.
Yeah, and I think the more and more we unpack this, Vivek, the more and more I'm realizing that at the end of the day, the way you set up the rewards and the losses, uh, that's what's going to dictate tomorrow the reliability, the way this model engages with public, the right or wrong decisions it makes. Who's going to be responsible and accountable if an AI model doesn't perform the way it does. All of that finally can be traced back at the end of the day to this, right?
Yeah.
It's the how you're setting up the rewards and how you're setting up the losses. I'm hearing a lot about AI models training other AI models, right? And as we unpack this, I don't see that as a near-term exercise at all, because there's so much human input that has to go into this initially, right? So, do you see that future of AI training AI, or at least in the near term, next 5 years?
So just yesterday, I was reading a paper about using what I call verifiers. I won't get into this, right? But using verifiers on a certain like math problem corpus to dramatically kind of speed up, the efficiency of fine tuning, right? And that's an example of kind of like multiple models, at play, right? So, and that idea is very old, right? So coming back, since this is about reinforcement learning, a very old kind of like abstraction, shall we say, right, within the world of reinforcement learning algorithms is this notion of actor-critic algorithms, right? And so the idea is there's an actor and and a critic, right? And basically there are these two models that are simultaneously kind of acting and then critiquing those actions at some level, to kind of figure out how to interact in the environment. So at some level you could kind of formulate that as AI training AI or whatever. But I think there's obviously, as people talk about this, there are undertones to AI training in AI which I'm not capturing in what I'm saying, right? For instance, you could sort of say, hey, look, often when people think about AI training AI, right, they're thinking about what happens when the data tap kind of turns off, right? So if you sort of think about where we are, the existing sort of pre-trained models have kind of gorged on decades of data, right? Like the internet, effectively, right? But at
Mm.
some point, that plateaus. No, you don't,
Yep.
right? That part plateaus,
Yep.
and so you ask yourself, well, how do you get the next, right? Like, how do I get the next level of improvement? I don't. I think the jury's out there, right? It's completely unclear, what happens. And I think this is more a philosophical question. Do things plateau? Do they not plateau? If they don't plateau, how don't they plateau? Maybe you become much more efficient with data. That's clearly one thing to do. But maybe there's kind of a synthetic way of generating data and then critiquing that somehow, right? And maybe that's a different way of doing things. So kind of unclear, to be honest. Oh, by the way, just to kind of close the loop on the LLM story, right? I did talk about RLHF, right? Reinforcement learning with human feedback, and we talked about the human feedback part, but I actually did not talk about the reinforcement learning part, right? Like, where does that come in?
Sure.
And really, that comes in a really uh, tactical sort of way. The RL in RLHF was basically take the reward model you learned from human feedback and now apply more or less an off the shelf RL algorithm to that. The RL algorithm that gets very commonly used is an algorithm called PPO, right? Apply that algorithm. And then hopefully that algorithm optimizes, the underlying model, right, to produce answers that maximize, the reward that we came up with. Last thing I'll say, it's unclear whether actually you need this sort of formalism, right? It's unclear whether the RL formalism is even needed. So just to summarize, right, that whole chunk, right, RL has had a very important role to play, right, in kind of shaping, kind of in essentially doing alignment, right, like getting aligned models out of pre-trained models. But it's just an algorithm, okay, over there. In that context, it's just an algorithm. It's an algorithm for optimization, and as such, other algorithms such as the ones I mentioned just now, this DPO thing, for instance, might be kind of more effective.
Very interesting. Vivek, are there any other ways of learning that we are experimenting with in terms of is RLHF? I know that's proven right now to some degree, and as you said, there's different ways to incorporate it. Um, are there any other methodologies of learning that are being experimented with?
Yeah. So certainly in the LLM context, like in the context of alignment, right, which is not reinforcement learning, right? It's alignment. It's a different thing. In the context of alignment, so conceptually, it's actually very simple, right? Conceptually, the notion is really what is the core data, right? The core data are the preferences, right? That's it. There's nothing
Yep.
else. That's the core data. So can we go
Yep.
directly from the preferences at some level to the optimized model, instead of doing this kind of
Hmm.
weird thing of building the reward model and then doing whatever and then whatever, right? Like, which feels kind of like a little bit indirect. And so that's kind of the general sense. That's kind of the general direction. But obviously, there are reasons why that general direction isn't as mature. It's for the simple reason that basically there's just a lot of code available to do things the first way, right? RL has been around for a long time. PPO, that algorithm I talked about, very mature code bases for PPO because it gets used for lots and lots of different things, right? Whereas for these newer things, there aren't as the code bases aren't as mature and so on and so forth. But to the extent that they prove to be more sample efficient, which, I mean, this is like all very fresh stuff, right? It's months old. To the extent that they prove to be more sample efficient in this context, I see no reason why there won't be more emphasis in that direction.
Amazing. Vivek, for our business leaders, could you tell them a little bit about so if I'm the CEO of a company and I'm integrating AI foundation models or LLMs into my products and services, and those gray areas that you call judgment, right, of how a model behaves, how a model performs, what should I be looking at in order for me to ensure? So, for example, Apple has such a strong policy around privacy. Other companies don't. Every company is a little different. Some companies have a strong policy around diversity. Other companies don't. So, as a company CEO, if I want to make sure that my policies, my values are reflected in the AI models that are being trained and being deployed, obviously I have to pay close attention to this area of RLHF, right? Because that's how these models are getting trained.
Totally.
So, what should I be looking for? What questions do I have to ask my team?
That's a tough one. So I don't know if anybody knows the answer there, and I'm happy to prognosticate, right?
Yep.
So I think there's a lot of issues, right? I think there's tons of issues. Just so they're clearly the issues that you mentioned, right? Which is at some level. In fact, I can just like I can make it really simple, right? So let's say you're building a customer service agent, right? So it seems like a generic thing to do, and you don't want your customer service agent to curse at your customer. How do you protect for that, right? Well, if it's something like curse words, that's probably pretty easy because there are published lists, right, of kind of dirty words, and you could just sort of say, listen, don't produce dirty words, right? Like I'll filter against dirty words. Yeah, well, I won't let the model produce this. So that's an example of a guardrail, right, for the model. I'm not letting it produce dirty words. So now you can say, okay, wait, great, done that, check, right? But you know what? Like I can actually be very mean to someone without using bad language. Right? I can
Mhm.
speak, the king's English or the queen's English or whatever, and still offend someone very deeply. I can again kind of like manage the model to do this. I can tell the model about concepts that it needs to avoid, right? Like I can sort of I can clearly filter for certain concepts, right? I can say, hey, you can have a critic, so to speak, right, at some level, or a verifier, more in today's lexicon, kind of look at the answer that came out and sort of say, yeah, you know what, this has like nuances of whatever, of misogyny, right? This has nuances of
Mm,
whatever, right? Like they can't do this, right?
mm.
So let's filter for
Okay.
that. But then you could go one step further, and people can like get your model to say bad things, right? So a great example of this is so Zico Coulter is a professor at CMU, and he works on this. He works on lots of things, but like one of the things he spent a lot of time on is optimizing against neural networks. So optimizing the inputs of neural networks. And one thing you can kind of think about is coming up with adversarial inputs, right? You can use this to come up with adversarial inputs, right? And so one of the things Zico's group has been able to do is produce really attacks, so to speak, on ChatGPT that get ChatGPT
Mm,
to break its own guardrails, right? So you can put in
mm,
prompts that sort of get ChatGPT to tell you how to build a bomb, for instance, right?
mm, mm,
And you can
mm,
you can kind of succinctly optimize against this. So I think if
mm,
you're a CEO, I think there's like levels to worry about, right? So if you're deploying AI, in the back end, right? Like in guiding a customer's journey through a website or something like that, or whatever, right? I think that's very low stakes in terms of these concerns, right? Why? Because
mm,
fundamentally, the set of actions that the AI can do is limited, right? It's limited to
mm.
this page and what it can place on the page and the options it gives you and whatever, right? Like I think it's exciting to use this, and some of these worries are much less kind of troublesome. I think where it starts getting much trickier is when you start taking, kind of text and answers and things like that, and putting that in front of, the end customer, right? Without
Wow.
a human kind of monitoring every answer you give, because even with our current framework for doing this is patchwork, right? Like I just explained, it's literally patchwork, right? Here's one way you can screw up. Okay, I'll plug that hole. And there's another way you can screw up. Okay, we plug those holes, right? But like if you're running a big business and you're answering, I don't know, 100,000 queries a day, even if two of those queries are off or one of those queries is off, that could be like a PR disaster, and more than a PR disaster, just like, not good for the company. So I think when it
It
comes to
is.
kind of that level of usage, I know that there's a broad spectrum in how excited people are, but I think we've got to be honest that, like, our way of kind of guardrailing these models is more of a patchwork as opposed to anything else, just because of the fundamental nature of how these models work.
If somebody doesn't put AI in front of the customer, you're never going to learn. And that brings us to the last area of discussion today, which is your company and you've been working a lot on figuring out how to take these LLMs and or how do you train large language models to be used in the world of retail, right? And you have some really interesting use cases, especially the ones where it is not as controversial and business leaders can leverage them early on and quickly. So why don't you tell us a little bit about that? How are you using this concept of RLHF to sort of change the world of commerce? What's your vision around it? Tell us a little bit about what you're doing.
So a couple years ago, my research group started working with folks at ByteDance, right, to think about really making, at least the reason I was excited about this project, it was about kind of making TikTok healthier, right? So, in what sense? We would like people to have a healthy amount of interaction with the platform, right? Which is to say, don't binge for like 9 hours straight, on the app. That's in no one's interest, right? Instead, we want kind of continued, sustained, but healthy usage, okay, over time, right? Um, and the perspective was, look, if I kind of think about ByteDance's infrastructure, right? It's ultimately like it's ultimately one giant recommendation system. That's how you might think about it, right? But it's one giant recommendation system with like 80 million knobs. Right? There's 80 million dials and knobs that you can kind of tune. And one way of approaching that, right, is to sort of think about just running A/B tests, right? I could just A/B test things, right? I could tune a knob a certain way, and then so on and so forth, and whatever. But this quickly gets out of hand, right? Even at the scale of TikTok, there's only so many A/B tests that you can run. It's not a particularly this is not a particularly efficient way of exploring that space of how to interact with the customer, right?
Yep.
So here's kind of like an alternative way of thinking about it, right? So imagine that you thought about your customer now as one of these large language models, right? So what is the customer doing? In the case of TikTok, it's something really simple. You show up, you click on a video, you watch it for a certain amount of time, then you see a feed of videos, maybe you click on another one, you watch that for a certain amount of time. Occasionally you might search for something, you might see something, you might get some results, you might click on that, you might interact in some other way. Eventually you leave, right? And then a day later, maybe you come back, and this whole game continues, right? So as opposed to generating, tokens, right? You're generating actions, right?
Mm.
Against the same kind of uncertain environment, right? So one way of thinking about the customer then is to say, like, listen, like maybe, right? I think of modeling the end customer in the same way as I might think of building a large language model, right? So let's say you did that, right? And now let's say in addition to kind of doing that, right, you sort of say, look, as a platform, I have a very clear objective, right? What is my objective? My objective is I don't want you to binge because it's just bad for everyone. you included, right? Instead, I want like a healthy amount of consumption. And I measure that in terms of, there are many metrics I could measure that in terms of, right? If that's my objective, how do I control the token generation process, which in this case is basically how I interact with the customer, right? Or in the case we were playing with, maybe knobs that you tune to kind of maximize what ends up happening, right? So this was kind of a concept that we thought about quite a bit, and in fact, a bunch of our work is actually in GA at ByteDance, right? Around this concept to sort of basically be able to say, can we extrapolate to what the right way of doing things is without running like a huge number of like very expensive A/B tests, right? Can we do that with a much cheaper A/B test, so to speak? Okay. So that's kind of a little bit of background, right? In terms of what we're trying to do at Simulate, so we're sort of trying to say, look, that concept can apply to anybody with a website, right? Where in effect, you have a model. We kind of like, there's a little bit of marketing shtick around this, right? We call it CGPT for customer GPT, but it's just a large language model that's trying to capture, customer behavior, right? So you have this large language model that's kind of capturing customer behavior. How do you learn this large language model? Well, in two ways, right? You learn it basically, one, from kind of first party data, what's happening on your site. But pre-training is also very, very valuable here, because ultimately, if I think about, how I read a web page, well, like things like the common crawl and so on and so forth are really well suited for that, right? So I can use pre-training to really understand how to kind of, represent a page and read a page and so on and so forth. And that way I can really kind of leverage the first party data to kind of understand dynamics specific to this site, right? So, okay, so now I've got this like CGPT model, whatever you want to call it, right? I can now think about optimizing interventions, right? Controlling that token generation process for whatever reward that you might actually care about, right? And this is fundamentally an RL problem. The rewards we find to be very, very valuable on websites, right, are rewards that effectively think about not just myopic things like maximizing click-through or whatever it is, but more holistic rewards. So for instance, I'm on a website, I put something in my cart, right? Wouldn't you rather that, the next thing I put in my cart ship out of the same warehouse? Right? That immediately maximizes, kind of like, that reduces that improves your operating margin dramatically, right? Or hey, like, look, I've got all of this stuff in inventory that's really not turning, and I've got all this other stuff which I'm running really short. From an inventory cost perspective, maybe you really want to get rid of like some of the stuff that's not turning, right? How do I kind of balance that? So we find that businesses have fairly complex objectives, and we can now bring that holistic objective to bear on pretty much any interaction with the customer on the website. Where we're focused now is primarily search. We find that like basically just changing the way enterprise search works, changing, for instance, the set of results or the ranking of results that gets returned, can really kind of maximize sort of the value of the session. And again, the underlying story is just it's the same vein, as what we were talking about.
And Vivek, you in this program, so essentially me as a customer, I working with Simulate, I can decide what those rewards are going to be, right? And I can decide what those objective functions are going to be. This is phenomenal. And when can customers expect to have this platform so that they can work with it?
So we're in beta right now with 4 or 5 design partners in a bunch of different verticals, ranging from kind of like B2B, B2C, to all sorts of, right? So a bunch of different verticals. We anticipate being in GA in the next couple of months. Please like reach out to me or John Andrews, my co-founder and CEO. We're very eager to sort of engage in conversations, at this stage. We are focused on our design partners right now and kind of making them super successful. But it's never too early to kind of start that conversation. So, yeah.
Fantastic. Yeah, and I encourage our our listeners to reach out to Vivek. If you want to learn more about even reinforced learning or RLHF, you can see Vivek's background in this area. And I think Vivek, the in this conversation, you really brought out how important this learning mechanism is and the implications this is going to have for all our futures, right? From revealed preferences to which options do you take, we unpacked a lot today. And I really think it's important for business leaders to pay attention to reinforce learning and what it means and how your models learn. And if you're more interested in this topic, do reach out to Vivek. And also, if you're looking to deploy artificial intelligence as a part of your e commerce program so that you can make better decisions and help your customers have a better journey, do reach out to Vivek and John, and they can tell you about how you can optimize a customer's journey through your e commerce windows and channels and how to better optimize it for your profit. So, thanks everybody. And this was a great session. Vivek, thank you so much. Fantastic having you here with us. We went a little longer, but I think it was worth it. A lot of great information from you. Really appreciate you spending the time with us today.
Thanks, Arvind. It was a pleasure.
Take care, Vivek.
Okay, take care. Bye.
And can you give us the heads up on what to expect from next week's interview? Who are you going to be talking to?
Well, Stuart, I think in our next episode, we're going to learn from Anupam Datta. He's a professor from CMU. And we're again going to go, today we spoke a lot about AI training, but with Anupam, we're going to go even more first principles. We're going to talk about what does an AI model mean? What does it mean? What is an AI model? How is it developed? What does it mean? We're going to kind of really go down to first principles of AI.
Something to look forward to. So that's it for today. Thanks as always to Arvind Ravishankar. It's always good to talk to you, Arvind. If you like our podcast, please like, subscribe, or tell a friend. I'm Stuart Black, and see you next time on Unpacked.